and I'm going to. Right, so Peter and I voiced this presentation the end of last week. It's put together. In fact, if you haven't read the paper, it's in the March Report magazine, a copy of which you've got. I'm very grateful to Peter for bringing this up as a discussion point. And it's all to do with the fact there is no regulation, essentially, in how thick steel should be. And we're going to get you to, as I say, do a bit of audience contribution on that in a minute. So we're going to play Peter's video. It's about 15 minutes, and then we'll get into a discussion thereafter. So, Dave, are you seeing my screen?
Aye.
Fantastic.
Narrowboats.
Okay, here we go.
This presentation is to explore the minimum steel thickness for narrowboats, being written by Tom Keeling and Peter Brookes. Tom has been working in the Inland Waterways industry for 38 years. He's a self-employed marine surveyor, a boat safety scheme examiner, and has been gas safe registered since 2005. I have been a chartered engineer since 2009. I'm also a boat safety scheme examiner and gas safe registered. This paper explores what steel thicknesses are required from the design stage to provide adequate structural integrity of narrowboats. It explores the publications about permissible wastage before repairs are required. It explores what classification rules have to say. It explores why narrowboats are generally built using significantly greater steel thicknesses than the scattering calculations require. During the course of writing the paper, it involved discussions with surveyors, insurance underwriters, and boat repairers. It seeks to begin an informed debate about what we, as surveyors, should consider to be a minimum acceptable thickness before repairs are mandated. Research for the paper began during 2022 after it became apparent that there were many different opinions about what the minimum acceptable thickness for a narrowboat should be. I'd like now to throw out to the room and to all those who are connected remotely, just to have a look at the different options we have here and to vote on how you base your decision making when you carry out a survey on a narrowboat. I'll hand over to Mike to count out the responses to the different choices.
Right, so there we go. Just see if I can just stop the share. Can I stop the video?
There is no currently agreed minimum core thickness.
Sorry, guys, it's the operator error again.
Today's survey review
We will come back to it.
shown that there are different opinions on acceptable minimum thickness. Research. There is no currently agreed minimum.
Dave, I can't stop the video. Can you come and help me here? No, I can't get to it. I can't get to it. I just can't get to it. I think I've stopped it. No, I haven't stopped it. I can't get to the button. It's hidden by that.
There is no currently agreed minimum
Just
core
pull this back to you. Get that the numbers on.
Yeah.
We share. Yeah, thank you. Right, sorry about that. It's operator error here. Okay, so those of you online, if you would like to pop something into chat or pop up online and voice your opinion, whatever you want to do, and those of you in the room, what we want to know is what you think is an acceptable minimum thickness. for a narrowboat at the time of survey. And I know some of you don't do narrowboats, but that doesn't matter. You may still have an opinion on what you think minimum thickness is. As you know, there's no regulation because we've seen that bit already. So any votes, any offers for 2.5 mil, 2.5 mil? Anybody think that's okay? Anybody online, if you want to pop something in chat, if you think that's good.
Yeah, no, 2.5 mil is no good at all.
Thank you, Jeff.
The reason I say that is because the MCA do say that vessels under a certain length have a minimum hull thickness of 3 millimeters. So if you're listening to the MCA route, then you're stuck with 3 millimeters as a minimum anyway.
Hold that thought.
Sorry?
Hold that thought. So then, who thinks 3 millimeters is an acceptable minimum thickness? Got some coming in on chat, actually. Let's just see what's coming in on chat.
What we're talking about here is actual sheet thickness, not the remaining thickness after diminution when the corrosion is set in. So when the vessel is constructed, 3 millimeters, I mean, you know, because some vessels were actually built of 3 millimeters. Yeah. And lots of narrowboats were built in 3 millimeters as well.
Okay, so then who thinks 4 millimeters is an acceptable level? Oh, some hands going up in the room. Right, so we've got 3 people in the room. Got a couple online. Chris Holmes says 4 mil with pitting, up to 1 mil deep on 6 mil plate.
Depends.
Well,
Yeah. Whatever depends where it is.
So Fergus says percentage of the original. Somebody here says 5 mil. So who thinks that more than 4 mil is an acceptable thickness? What, 1, 2? So 2 people think that. I hope someone at the back is recording this. Dave, would you? Oh no, we're recording the session anyway, so that's fine. I've also got 3 millimeter springers. I know about this.
Yeah, springers were built in 3 millimeter plate, or the majority of them were. So on that basis, all Springer narrowboats are no good then.
So you can see where this is going, can't you? So 5, a percentage of the original hull thickness. Who thinks that is the way we need to go with this? A percentage of the original hull thickness, not specifying what the hull thickness is. Any votes for that? Well, we'll come on to that in a minute.
That's where I was landed, but actually Jeff said this was from the starting point.
Yeah, hold your thoughts, Jeff. Hold your thoughts, Jeff. Don't jump in yet, Jeff. I can see you're like champing at the bit there. John Leach has said percentage of the original plate. What about number 6, at the discretion of the surveyor? Who thinks that's appropriate? 1 or 2 nodding in the room and 1 hand gone up. So yes, there's 1 or 2 votes for that. But what about 7, at the discretion of the insurance company? Yeah, some nods going on in the room and 1 hand gone up for that as well. Tim Rose says 5 is a better fit with class rules. So there's another opinion. Gosh, it's complicated, isn't it? Any other comments on that before I'm going to release the rest of the video?
But I think more to the condition of the vessel, not an opinion as to whether the steel is thicker. I think it's my reference to the insurance company making a decision, the buyer or the owner.
Hold that thought as well. So what I'm going to do is let me play on and get to the end of the presentation, then we'll get into a debate about this.
How you base your decision making when you carry out a survey on the narrowboat. I'll hand over to Mike to count out the responses to the different choices.
Okay, we've done that.
There is no currently agreed minimum core thickness for narrowboats. Today's survey review has shown that there are different opinions on the acceptable minimum thickness. Research by Tom and myself has shown that there are many different opinions and different reasoning behind those opinions. Insurance companies, who have been told, have differing minimum thickness requirements, with one in particular stating that they set a minimum of 4 millimeters for commercial and risk reasons, since it reduces the risk of any claims significantly. So, what is the thickness of a new hull? The boat built today may well be 10 mil base plate, 6 mil hull sides, or top sides. Springer Engineering, who were a prolific boat builder, frequently used 3 millimeter or 5 millimeter steel plate. Please bear in mind that there are 1,266 Springer narrowboats still in use on the Inland Waterways today, and these will all be subject to survey. There's a number of ways to calculate the scantling requirements. But today, most boat builders use experience and practice, with hull thicknesses tending to be over-engineered compared to the
Mike, we've lost sound online.
It's not usually a new boat that we're surveying, and therefore we have to take into account any corrosion or wastage that we might find. Depending upon the age of the boat and the original build, this can result in very different results. Our research indicates that acceptable wastage by different classification societies can be 20% or 25% of the original plate thickness. Bear in mind that the scantling calculations for a 50-foot narrowboat calls for a bottom plate thickness of between 3.35 millimeters and 5 millimeters, which can be subject to a 20% and 25% wastage and remains acceptable according to the MCA 2022. Therefore, if you're working to a percentage wastage on the narrowboat base plate that was 15 millimeters, should you condemn it when it drops to 10.8 millimeters? Food for thought. We went out and asked various insurance companies to comment on what their minimum thickness requirements were. We have replies from 4 underwriters included here. Some chose not to reply at that time. As you will see, there is no agreement between insurance underwriters. Boat owners who are insured with Insurer D may have no insurance cover if the minimum plate thickness of their hull is less than 4 millimeters. And if they've not had their hull surveyed recently, they won't have any indication on whether they're insured or not, i.e. whether their remaining thickness is less than 4 mil, more than 4 mil. Seems slightly unfair on boat owner to put that in small print on their policies. Here we have a hypothetical situation. I'd like you to read through it and just think through whether you would consider this repair to be acceptable or not. There are two possible answers here. Either could be justified, but both could be subject to criticism. Taking the hypothetical boat, if the wrong repair decision is made, then the owner might be faced with another significant repair bill. The owner may seek to recover his losses from one or other surveyors that might be involved in this, resulting in time-consuming litigation. So hypothetically, a boat owner here has spent £12,000 having his hull repaired with metal spray, shot blasting metal spray, and then 2-pack epoxy coating. When he came to sell it on, when his circumstances changed, found he couldn't sell the boat because the pre-purchase survey flagged up that it required a complete overplate. The owner, understandably, could be quite upset about the situation and would be seeking to recover some of his losses from one or other of the surveyors. Coming back to the fundamentals, why do we measure hull thickness? Check the boat is safe, check whether it's likely to sink, check if the boat is insurable, check if the boat is resellable. The MCA, in their document, Instructions to Surveyor, Construction, Watertight and Weathertight Integrity, MSIS 27 revision 8.022, states, isolated areas of pitting with a depth not exceeding 50% of plate thickness may be repaired by welding, subject to the use of qualified welders, and approved procedures and materials, e.g. classification society approved. In general, hull plate areas below 3 millimeters in thickness should be renewed. Now this refers to fishing vessels subject to wave action in the open sea, not narrowboats operating in sheltered waters. But it gives us a good indication of what the MCA would consider to be a minimum thickness for a steel vessel hull, steel hulled vessel. People affected by this, the boat owner, in the way of the safety of the boat, cost of any repairs that are specified, the ability to get insurance cover, the ability to sell the boat on, and potentially the condemnation of what is his home. The surveyor can be affected by loss of reputation, either being too harsh or too lenient during the survey, and potential time and cost of any litigation that they might have to defend against. Due to the lack of there not being an industry-wide minimum for thickness accepted in the industry, surveyors are not able to work to common standard, and therefore there is a potential for litigation due to different opinions. Boat owners might be required to spend excessively on repairs that are not actually required. Where do we go next? I would suggest that we could have a multi-agency agreement a meeting between surveyors bodies, insurance underwriters, and boat repairers, where we agree a standardised requirement to work to. Failing that, perhaps as IIMS, we put out a decision, a determination on what we require, what we determine to be the minimum thickness, and then invite other parties to agree to that. Following this work, we need to carry out more work to agree approved repair methods for narrowboats. There's, again, lack of agreement between whether epoxy coatings that stop corrosion are adequate, or whether vessels should be overplated. So that is another piece of work that we should move forward onto afterwards. We would really welcome your feedback. I hope that you feedback to IIMS, to Mike, to Tom at info@smallcraftservices.com, and to myself, Peter at technicalsupport.ltd.uk. Copies of the paper can be found on the IIMS website or at www.technicalsupport.ltd.uk/technical. We look forward to your feedback and your input into this. Thank you.
Right, so big thanks to Peter for pushing this into the limelight. It was Jeff who started this, Jeff Waddington. I've asked Jeff, he's in Portugal at the moment, but thank you, Jeff, for popping up online today. We've got 20 minutes. I wonder if you might like to sort of lead this discussion and see where we go with this. I think what I would like to achieve out of this is multi-agency is interesting. It would be great if we could get all of the institutes and associations to come together as one standard. I suspect that is not going to happen. But I think if IMS were to take the lead in this, Jeff, and I don't know if you agree with this or not, and develop something and then try and invite the others to sort of jump on our coattails is probably the way to go. I don't think we want to be sitting in a committee meeting with a load of other organisations. So we can agree something that we think is realistic. I think where I have a big issue with this is that people buying narrowboats and potentially they can't insure them. And that to me seems horribly wrong. So we've got a bit of work to do with the insurers and the underwriters. That's fine. We know who to speak to, but it's what we're telling those people. Jeff, perhaps you might just take us back to where you started from with this a couple of years ago. And obviously Peter's picked this up. And what do you think we need to do going forward?
Well, I don't think it's for the IMS to set a standard for a start. I think the standards need to be set by the people who have set the standards, which is the classification societies and the MCA, because they've set the standards on the wastage that you can have and the percentage of wastage. I mean, a lot's been said about this because it's a very difficult subject, because if you go into panel strengths, which is what the steel thickness is all about, then it depends upon the strength of the panel is dependent upon the amount of framing that's supporting the panel. So when you look at individual craft, you can have quite a lightly built craft that's got a lot of stiffening in it, or you can have a very heavily built craft that doesn't have a lot of stiffening in it. And then you've got this other muddy water bit where you've got this bit about inland waterways craft that don't suffer wave action. And the problem, I wrote some articles about this because I had problems with inland waterways craft, and I got involved in a lot of legal cases against surveyors who had been surveying inland waterways craft. And the biggest problem they have as surveyors of inland waterways craft, not that I am, but it appears to be a complete lack of facilities on inland waterways to correctly take these things out of the water for routine maintenance. So that's why they're putting 10 and 15 millimeter bottom plates on, because nobody is ever going to see the bottom of the boat ever again once it's built. Because when it comes out of the water, it's not lifted high enough for anyone to get underneath and have a look. So they make it of steel plate, a thick steel plate, on the assumption that it will last a long time before it wears out, which is not really the way to do things. They should be taken out of the water, blocked off properly, at least a metre off the ground, so that people can get underneath, maintain them, and survey them. Unfortunately, this is not the case. So that's why a lot of them are falling foul, because the surveyor can't inspect the boat properly, and meanwhile the boat's been corroding away. So percentage loss and the amount of pitting is all down to, I would say, to the percentages which are laid down by the classification societies and the MCA, which in general is between 15% and 25% loss, depending upon the position longitudinally. That leaves you with about a 20% average wherever you're looking on a boat. And then pitting is similarly, if it's 5% pitting, you can probably repair it with epoxy, just filling it in, because it doesn't really weaken the panel that much if it's only 5%. But if you've got 25% pitting over an area of 1 square metre, then you've got a loss of material strength, in which case it's got to be repaired. Then we're down to, well, how are you going to repair it? So we've got a lot of people still go down the, I can't afford to have it repaired properly, I'll have doubler plates put. And a lot of these inland waterways craft have already been fitted with doubler plates around the waterline, because it's the wind and water line that corrodes first. And then you get the surveyor going to look at the boat, which has been doubled, and as far as he's concerned, it looks perfectly well. But you don't know what's going on behind the doubler plate. And you don't know whether the doubler plate was actually welded and attached to the internal stiffening and structure. So doubler plates were basically banned by classification societies, but then they're more interested in seagoing ships. It has to be repaired by inserts. Doublers are only a temporary repair. So I'll throw that one into the water and see what happens there.
Thank you, Jeff. Right, who wants to contribute something to this? I know there's a number of you in the room who do look at narrowboats, and even if you don't look at narrowboats, you may well have an opinion.
It's very interesting in the presentation where they sought the opinions of underwriters, and the underwriters that are part of the, you can see this in the report, who said any 3mm plate should be overplated before insured. Any welder will tell you, try to weld into 3 or 2mm plate is virtually impossible.
Well, Jeff is a welder, so Jeff?
Really hard to do, but it's interesting that the insurer's perspective is the answer is overplated. And that's what I found very interesting from the comments from the underwriters made.
It would be also interesting to know if those insurers introduce anything along the lines of changes to freeboard as well, when they're suggesting that overplating taking place.
I don't know if you're picking up that conversation, actually, Jeff. Changes to freeboard consideration by insurers, underwriters?
Well, yeah, there would be an increase in weight, perhaps, yeah, to be considered. But I mean, it would be minimal, I would think, depending upon the amount of work that's being undertaken.
I sunk on the Thames a spring, I got overplated, and there was an air-cooled blister, and they didn't take the extra weight into consideration, and it went on the tidal Thames and sunk. It's a big case. That's about 10 years ago.
Yeah. So, Jeff, what is the way forward with this?
Well, I think from a surveyor's point of view, when you're inspecting these boats, because the standards and the variety of construction vary dramatically, you've got to take each one as you find it, really. So if you're looking at a boat that's been designed and built in a certain way, what you've got to say is it still as it should, as it was intended to be? Has something changed? Is there some severe corrosion or some loss in some areas? Do the stiffeners need to be replaced? Does the platework need to be replaced? And if so, should you be doing it in accordance with how the boat was designed? Which of course you should, because that's how the designer originally worked out all the panel strengths and the longitudinal stiffness of the vessel. So you've got to work within the parameters that you're given. The issue is making sure that you do cover all the areas. Most of the surveyors who get into trouble fall over because they didn't manage to actually inspect the parts of the vessel properly. And the problems with that is access. Access, especially with narrowboats, is a major issue because you just can't get to the inside of most of them. You might be able to get in the inside in a couple of places, but most of it you can't see. And then if you can see the outside, I mean, you know, Mike, we had one chap who actually inspected a narrowboat from the opposite bank. Now, I'm sorry, when you're inspecting a narrowboat from the opposite bank, you might just as well put your head on the railway line and wait for the train to come, because you just, you know, this is just ridiculous. You can't do a drive-by survey on a steel boat. You know, steel is a bit of a problem, and I see somebody's already said that's why I don't do steel anymore. And I can appreciate why you wouldn't want to do that. It is difficult. And thickness is, and everyone talks about thickness, but then what is thickness? You know, if you're using an ultrasonic thickness gauge, I mean, you're checking to see what the boat was made of, but then it's not actually telling you very much if there's corrosion on the inside, which is masking the readings. And you might check it in one place, a bit like a GRP boat, really. You check it in one place and there's a problem somewhere else, which you're not seeing. So it's the pitting and the general condition that you're more interested in. And like our good friend Geoffrey Wood would say, get out a big hammer and give it a good smacking. Because, you know, a hammer will soon tell you whether the boat's sound or not. If it's got a ring and it's not denting or collapsing under the weight of the hammer, then it's probably okay. If it sounds dull and starts to flake and fall apart, then it certainly isn't. It's not an exact science, and it is down to the surveyor on the day, and a lot of that is down to the conditions of survey and the access.
So Chris Holmes has just popped up and said there is no access to most of the interior steel surface and the stiffening.
That's right.
So
straight away you've got a problem.
I'm going to say you're screwed before you start, aren't you?
Most now are a very pretty wooden box built inside a very pretty steel box with no access to the inner surface.
Yeah.
I mean, if you remember the Clipper sailing yachts that we had problems with, and we had to have them rebuilt years ago, it all boiled down to the fact that when we were inspecting them, all we could see was a hairline crack in the paint on the outside of the boat. There was a slightly red hairline crack, almost like a little vein in your arm. And that was the clue to what was going on. Once the fairing compound had been taken off the hull, then we could actually see what the extent of the problem was. You couldn't do it from the inside because they were all covered in spray foam on the inside. So you couldn't actually see what was going on from the inside either. And all this was going on behind the filler. And it wasn't until the filler failed and cracks started to appear that we realized that there was a problem with the hulls.
Yeah. So Jeff, one of the things I've heard anecdotally is that builders are building to 4 mil, and the surveyor goes along with his or her thickness gauge, does a check on it, and it's 4 mil, and it's 4 mil, and it's 3.9 mil, and it's 4 mil, and it's 3.8 mil, and it's 4 mil, and it's 4 mil. And because there's a one reading or two readings there below 4 mil, they won't insure the boat.
Well, this is something that's come up with insurers only recently in the last 18 months, really, where some insurers have decided if there's plate work less than 4 mil, we're not insuring it. So that is completely the decision of the underwriter. They're not basing it upon any rule or anything else. They're just making it up as they're going along because they've had losses. So they're minimizing their risk by saying, well, in that case, I'm not doing any boats. If it's 3 mil, I'm not doing it. And that's why a lot of insurers won't touch springers. And it's not just springers. There are lots of other manufacturers out there that have 3 millimeter vessels.
And as Peter told us, there's 1,266 of those, I think it was, that are still floating around on the waters. So this is a problem, isn't it? John Leach says on chat, he's used his hammer. It's gone through several old barges and modern English narrowboats. It's far more valuable to me than my ultrasonic measurements. So that's back to the Geoffrey Wood school of whack it hard with a steel hammer.
I agree.
Yeah. And I do have a small anecdote to tell you. I don't know. I don't think Vicky and Dave were around then. Perhaps they were a couple of years back. We were in the office, and a boat owner, a narrowboat owner, rang into the office in real concern, saying the surveyor's destroying my boat. And whoever took the call said, well, what do you mean? Well, he's smashing it with a hammer. You know, what on earth does he think he's doing? And whoever took the call said, don't worry, madam, it's quite normal. That's what they do. So, I mean, you just keep the you know, the potential boat owner or the boat owner away at that point. You don't want them there when you're whacking it with a hammer because they think you're destroying their boat. But
That is becoming a serious issue actually, because the number of boats I've looked at recently have recently been very epoxy. It's retail canals, it's not the brand new epoxy, and the owners generally aren't there, but the brokers are certainly there. And it's a battle.
It is, the subject of coating is tricky. It's a bit like when a fiberglass boat is being copper coated. You will not win friends by getting your scraper out and scraping coupons to do wash survey. It's the same with a boat that's been, you know, when you get 2-pack epoxy, it's quite a brittle coating. So when you start twatting it with a hammer, you will with that.
Jeff, what do you think there? So you can't whack it with a hammer anymore.
No. Now you've moved on to onto another subject here: coatings and the protection of steel. Steel needs to be coated, needs to be protected. So, and bituminous is not the stuff of protection. But yes, I appreciate somebody mentioning 2-pack epoxies. Absolutely the way to go. And if there's a decent 2-pack epoxy scheme on the boat, then I mean your thickness gauge will work perfectly well, and you certainly don't want to go attacking it with a grinder or a sharp hammer or anything like that. I mean, if the coatings are intact, then that's fine. I mean that's basically it, isn't it? If it looks good, then it probably is good. The problem with most of these steel boats is they just don't look good, do they? They're all flaky paint. They've been painted with hundreds of coats. They've never taken the paint off. They just put another coat on, and in the end, they just look like the surface of the moon. And then that way, you can't really do a proper inspection because you've got to take all the paint off to do it. And they don't want to do that because it's expensive.
So I'm conscious of time here. We've got 4 or 5 minutes. Seriously, I mean, we do discuss this often, I know, Jeff, but I mean, should we be approaching underwriters? Do we just steer clear, or do we try and take a proactive kind of line with all of this?
I'm a liberal inland. It's a big problem. There's a lot of people I know who are not insured anymore.
So there you go. Lots of people uninsured.
I think we have to be proactive, because otherwise the insurance companies will dictate to us what the standards are.
I tend to agree with you.
We should be seen as the centre of excellence.
I agree.
And telling them what we feel is appropriate.
Yeah.
But I also agree with the multi-agency.
I think things like that is correct.
It is, isn't it?
This goes to 10,000 people.
Yes.
Whole industry.
Yes. Yeah.
That shows that you're taking the discussion seriously.
Yeah.
But it's going to end up in some fairly heavy duty conversations between technical expertise, which is obviously what this group is about, and insurance underwriting. And at some point they'll have to be a compromise, because they will always look to cover their risk.
Of course.
We've got to look at a pragmatic view of a boat and its condition.
Yeah. Yeah. Hello, Jan.
What's Jan's view on it?
Yeah. What's your view on it, Jan?
Steel boats, Jan. Any comments on steel boats? Don't touch him. Don't touch him, says Jan. Right, there you go.
So I'm with you, and a little story, true story. I was sat out next to a lady at an event in Gdansk or somewhere in Poland. I don't know how I ended up there, but I did. And we were sitting at dinner in a big hall, and I turned to her and I said, "What do you do?" And she said, "I'm an underwriter." And I said, "All right, okay, working in London." And I said, "What do you underwrite?" She said, "Bunkering." I said, "Oh, that's quite niche." So she was underwriting ships bunkering. And I said, "Oh," I said, "I've never seen that done before." I said, "I don't really know how it all takes place." And she said, "Well, nor have I." And I said, "Pardon?" She said, "No, I've never seen it take place." She said, "I sit in front of my computer and I just base what I do on data that's available from various sources. And that's how they base their decision." So it may well be that underwriters are simply basing their decision on 4 mil because it seems like a good idea. They picked that up somewhere, and
I think it's partly the MCA that brought that around, because I used to repair a lot of passenger boats that sold to steamers on the Thames, so I put new bottoms on pretty much all of them. And then if they were built in a 4 mil, 3.9, and the MCA failed them all, and I had to replace everything below the waterline.
yeah.
Well, underwriters base it upon the percentage of loss. So there you go, back to percentage of loss. Only they're not worried about the loss of steel plate. They're doing on the percentage of loss, how many claims they have. So if they have a lot of claims on 3mm vessels, then they say, well, we're not going to insure 3mm vessels anymore. We won't insure anything under 4mm, and da-di-da, really. And they're basing it upon the amount of claims that they have. That's their criteria, really.
Yeah.
But if,
It's the risk at the end of the day.
if they're getting claims on 3mm, then it says 3mm is not satisfactory.
Yes, I think 3mm probably isn't satisfactory. But of course, they're not going to tell you what they're getting claims on. But Jeff has a hand on this stuff because he's involved in some of the legal aspects of this and so on with insurers. But sorry, Graham, you wanted to say?
No, I just think there has to be transparency in various areas of this, and like, of course, insurers pay out claims on those. It might be that a lot of them happen to have 3mm claim. That doesn't necessarily mean that the 3mm claim is to blame for the claim. It just happened to be about with a 3mm claim they come up regularly, probably through age more than anything else. But rather than them saying we have lots of claims, well, how many claims?
Yeah.
What was the value of those claims? And what was attributed to a 3mm claim? Because it's more likely to be a 3mm hit in a 3mm claim than a 3mm claim. That makes sense.
Yeah. So I think that's what we're taking away from this, Jeff, is we've probably got a bit of work to do with the underwriters and insurers. And we do know how to do that. I just want to read a couple of things before we close out here from that come up on chat, which you guys won't have seen in the room. So Ollie suggests we could ask Karen later, Karen Brain, whether PI insurance goes up for surveyors surveying steel over GRP. That might be an interesting discussion. And Tim Rowe wants to say, Jeff, you have a good handle on the subject. Access is critical to inspect and repair steel vessels. Seagoing steel vessels rarely rust out first from the outside because you can see a developing problem and deal with it. The structural problems accelerate on the inside because of lack of access during build, original painting, and later maintenance. If the condition is such that any wastage can be halted by cleaning and painting that's good, as soon as you have to do hot work, it's bad. I would agree with Jeff that lack of facilities and knowledge for maintenance. I'm an indentured steel shipwright. So
I'll tell you a little story now. There's lots of stories. When I was a young ship repair manager, we had a large luxury motor yacht come to the yard, which had been in the Mediterranean for some years, and it looked pristine on the outside. But they said that they had a little bit of a problem at the bow, and could we repair it? So of course I went in, and what it was there was a cable locker in the forward section, obviously, of this thing, and because of access, you couldn't actually get to the bow because between the cable locker and the bow was such a small space that nobody had ever been in there since the vessel was built. So what we had to do was actually remove the whole of the cable locker, take all the chain out, so cut the cable locker out, and so we could get to the hull. When we got to the hull, we found out there was virtually nothing left in the bow at all. It had all corroded away. Because although it'd been sitting in the med, it'd been sweating away in the med, rotting away on the inside, looked perfectly good on the outside, but all the inside had completely rusted away. And yet you wouldn't have known it to look at it. But until you cut that cable locker out to get in, you'd have never known.
Brilliant, Jeff. Thank you very much, and thanks everybody for contributing. And this is an ongoing thing. I think it's a live topic. So to draw this to a close, I think, Jeff, let's take this offline. We'll definitely work with Peter Brookes and Tom Keeling. And if anybody else wants to contribute anything, but I think this is a piece of work IMS should get involved in. I never used to think that a few years ago, but I'm a bit bolshier these days as I've got older. And, just think if something's worth fighting for, then you fight for it. And I think this is a worthwhile cause. Yes, of course you can, Graham.
I think it would be useful if there was a single point of contact or a nominated name within it.
Yeah, I agree with that.
I'm certainly involved in other groups
that
would want to participate and are actually keen to participate. In this case of who they're speaking to.
Me. Make me the nominated point. And we'll go from there. Let's see if we can collate something and try and make some sense of it. And I will talk to Karen about how we get into those underwriters. She knows the underwriters. Funny enough, we've got a similar thing going on. It's not similar at all, actually, a different thing going on, but the same type of thing with insurers out in the Caribbean at the moment, who are also causing us some angst, and IMS members in Caribbean some angst. So I think the insurance market has changed in the last year, 18 months. It just feels the whole market is in a very strange situation at the moment. Brilliant, Jeff, thank you very much. Go and do some more welding and then have a swim out in your pool.
Yeah. Got a little bit of welding to do, yeah, and yeah, well, I've written quite a bit on this subject over the years, and of course, don't forget, I have got Unit 26 out there, which is a really good unit on steel and aluminium, and there's a lot of good information in there too. Just plugging it a bit.
Okay, thanks very much. Right, so we're going to break. It's 12:30 here in UK. We're going to take about a 30-minute lunch break, and then we'll come back.